Homework questions. Questions on any of the assignments, any of the homework assignments you're working on that you are not sure of, need to see again. Questions? Questions over the homework? Questions 1 through 3 on 4, 5. Those first 3 are just asking for the rational zeros. It is not asking you to solve them. Because the solutions, there's really not any, and the ones that are, because it's not meant to be solved. So I just picked random numbers so that y'all can work on doing the rational zeros. Now, what we're starting 4-6 with is the fundamental theorem of algebra. Fundamental theorem of algebra, this table shows several polynomial equations and their solutions. Repeated solutions are included. So if we look at the first equation, we have 2x minus 1 equals 0. The degree is 1. The solution for this here is 1/2, and the number of solutions is 1. The second equation we have is x squared minus 2 equals 0. The degree is 2. Our solutions for this are positive square root of 2 and negative square root of 2. We have 2 solutions. The third equation is x cubed minus 8 equals 0. The degree for this is 3 because of our x to the third. The solutions for it are 2, negative 1 plus I squared to 3, and negative 1 minus I squared to 3. We have 3 solutions. And the last equation is x cubed plus x squared minus x minus 1. Still, just like before, the degree is 3. Our solutions for this are negative 1, and 1. We have 3 solutions. Now we have this table. Now the fundamental theorem of algebra, the actual theorem that we have, states that if f of x is a polynomial function of degree n, where n is greater than 0, it's not a constant function, then the equation f of x equals 0 has at least one solution in the complex numbers. So one of the solution is a complex number for any polynomial function. Even on the last few where it said x is equal to 2, well, we can say 2 plus 0i, it's now a complex number, which doesn't mean a whole lot to it. The corollary, what we can get from it, if a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each repeated solution is counted each time it shows up. So if a solution is repeated twice, it's counted as 2 solutions. Repeated 3 times, 3 solutions, and so on. So that means if we look at this equation here, x cubed plus 3x squared plus 16x plus 48 equals 0. How many solutions would this have? What's the degree? 3. So how many solutions should it have? 3. Since the degree is 3, the number of solutions should be 3. And this is good to know because if we graph it and the graph tells us we have 3 solutions, we know it should have 3 because the degree is 3. Interestingly enough, you don't have to write this down, but the solutions for this are negative 3, 4i, negative 4i. Guys, how many does it have? 3. How many zeros does the function x to the 4th plus 6x cubed plus 12x squared plus 8x have? What's the degree? So it has 4. And if we went and found it, the solutions would be negative 2, negative 2, negative 2, and 0. So even though negative 2 shows up 3 times, we still count it 3 times. It doesn't count as one single solution. How many solutions does this one have? 4, because the degree is 4. How many zeros does this function have? 3. All right. So x to the 5th plus x cubed minus 2x squared minus 12x minus 8. How many solutions should this function have? 5. Now this one didn't ask us how many solutions it had. It asked us to find all zeros of it. So we have to actually find the zeros this time. And we need to find 5. Because if we find 5, especially by graphing, we graph it, find 5 zeros, we're finished because we have all the solutions. But minimum, we need to find 3. So the first thing I would do is graph this. Grab the graphing calculator, hit y equals. Let's clear that out. X to the 5th plus x cubed minus 2x squared minus 12x minus 8. And we're going to graph this here. So we do see that it intersects or touches the graph at -1 and crosses it at 2. Direction. So again, when we graph it, we're looking for what value of x will make the y value be 0. So we do have -1 and we have 1 at 2. So, right, the minimum does need to be 3. Now, one of the things that we do notice with this graph, and we really hope, is at -1, does it cross? Does it look like it goes above the x-axis? Now, the nice thing with these is anytime these polynomial functions touch the x-axis but do not cross it, go from below to above or above to below, there's a chance there's an even multiplicity there. That 0 can show up more than once. Now, we do know it does work one time for sure. And we can use synthetic division to show that. Now, if it doesn't work twice, then we're going to have to use the rational zeros and go about other ways to find the other 3 zeros. Now, if we use -1 for the first one, -1 times 1 is -1. 0 plus -1 is -1. Then we multiply again, -1 times -1 is going to be +1. Add straight down, 1 plus 1 is 2. -1 times +2 is going to be -2. -2 plus -2 is -4. -1 times -4 is +4. -12 plus 4 will be -8. -1 times -8 is +8. And 8 plus -8 is indeed 0. Since we did get a y value or a remainder of 0, it tells us it is a solution. And we knew that from the graphing calculator. Now the hope is that -1 works again. Because if it does, it means it actually touched the x-axis and did not cross it. Now -1 times +1 is -1. -1 plus -1 is -2. -1 times -2 is +2. And 2 plus 2 gives us 4. -1 times +4 is -4. -4 plus -4 is -8. And -1 times -8 is +8. So our -8 plus 8 is 0. So we are able to say that -1 did show up twice. Which is nice. Because that means we can move on and try our other term. Now, it could be the case that -1 could work a third time, but if it does, it's going to have to actually work a fourth time too. Because anytime it touches the graph but does not cross it, we have to have an even number of those zeros. since it did work twice, if it's going to work again, it's going to have to work 2 more times. It's going to have to be an even amount every time. Now with 2, 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 4 plus 0 is 4. 2 times 4 is 8. And negative 8 plus 8 is 0. So now we've taken it from a degree 5 down to a degree 2. Since we don't have any solutions left that the calculator gave us, and it is a quadratic, so we can go on and plug the variables back in. And see that the final expression that we need to solve is x squared plus 4. And to solve it, we are going to set it equal to 0. Now, out of all the equations we can get, this is a nicer one because we do not have that middle term. We don't have that middle term of x. Because if we did have a value for x at x to the first power, we're going to have to use quadratic formula completing the square. Since we don't, we can actually use the square root method. We can get our x squared term by itself because our 4 minus 4 is 0. Telling us x squared is equal to negative 4. Since the x squared term is by itself, we can take square root of both sides because our square root and square would cancel, giving us x is equal to plus or minus, because whenever we take the square root of both sides, we have to put the plus or minus. Now we are taking the square root of negative 4. Whenever we take the square root of a negative, that negative sign has to come out as I, and the square root of 4 is 2. So it's telling us that the remaining 2 solutions are plus or minus 2i, positive and negative 2i. So if we want to list all the solutions out, we'd have negative 1, negative 1, 2, and plus or minus 2i. So we do have 5 solutions. Negative 1 showed up twice. We have 2, and then the positive and negative 2i. Questions on this here? Are you ready for the next one? Yes, sir. Yes. Yes, sir. Okay. Should work now. And especially on the test, if the calculator is not working right, let me know. Because what I normally end up doing is second plus tells, and I'll show you this here. Second plus is memory. I picked the 7th option to reset all RAM until it just to reset the whole thing. So if someone else or something got turned on somehow, we're just going to reset the whole thing. That way, everything goes back to working properly. We're just going to do a full reset. We ready for the next one? How many solutions should we have? 3. So y equals x to the 3rd plus 7x squared plus 16x plus 12. So we do see that it crosses, or it intersects the x-axis possibly at 2 places. It does look like there is a cross that's going up and over, and possibly might be coming back down. And both of those values are indeed negative, so -2 and -3. So the graphing calculator here, focus up here. -2 and -3 are two of our solutions. How many should we have? 3, because the degree is 3. So I do need 3 values. So we are going to do the synthetic division still. We'll have 1 for x cubed, 7 for x squared, 16 for x, and 12, and we will bring the first one down. Now there is a chance we do have repeated solutions, but really, at this point, it doesn't make a big difference, since all we're looking for is 1. We're going to get it down to a linear equation. And we're going to do this with -2. Now -2 times 1 is -2. 7 plus -2 is 5. -2 times 5 is -10. 16 plus -10 is 6. -2 times 6 is -12, and 12 plus -12 is indeed 0. Now at the -2 spot, it did look like it might touch that x-axis and go back up, so there's a chance it could be repeated. But since I already do, or we already have another solution to try, we're only looking for 1, might as well use it, and if it turns out that the other solution is -2, that's fine, we can solve it. -3 times 1 is -3. 5 plus -3 is 2. -3 times -2 is -6, and 6 plus -6 is 0. Questions on this here before we solve for the last piece? So it does look like it is -2. X plus 2 is equal to 0. We subtract 2, telling us yes. The other solution is -2. So that worked. That also means instead of doing -3 for that second synthetic division, we could have done -2, telling us that the final equation would have been x plus 3, telling us that the third solution is -3. But especially with the degree 3, they gave us 2. We need 3. Let's use those 2 and solve for the last one. Because it could be that it does cross at -2 and then comes back up at -4/5. It's just hard to see, especially on that graph. Questions on this here? Let's look at this one here. X to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4. X to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4. So we want to type the whole thing in and graph. And again, we're looking for at least 3, wanting 5 by the end, but we need at least 3 zeros. And interestingly enough, it looks like it did a similar, crossed it at -1 and then touched the x-axis at 1. So what we're hoping is that 1, positive 1 is a repeated solution. So when we do the synthetic division, if we can use 1 twice and we get a remainder of 0, it means it's repeated twice. It could be -1's repeated 3 times, but we don't know for sure. Because when it crosses the x-axis, it is an odd multiplicity, has an odd number of zeros there. So it could be 1, 3, 5. Well, in this case, it wouldn't be 5 because the total number of solutions is 5. So we can try 1 first. Now the numbers going across the top, we have 1 for x to the 5th, negative 3 for x to the fourth, 5 for x cubed, negative 1 for x squared, negative 6 for x, and 4 for our constant term. Now we'll start our synthetic division process. We'll do 1 times 1, which is 1. 1. Then we're going to add straight down. Negative 3 plus 1 is negative 2. 1 times negative 2 is going to be negative 2. 5 plus negative 2 is 3. 1 times 3, you good?
Yeah, okay.
Negative 1 plus 3 is 2. 1 times 2 is 2. Negative 6 plus 2 is negative 4. And lastly, 1 times negative 4 is negative 4. And 4 plus negative 4 will be 0, just like we wanted. Now, the next synthetic division we can do, we can move on and do negative 1 next. Or we can do 1. Either one works, or should work. We know negative 1 is going to work for sure. Negative 1 times 1 is negative 1. Negative 2 plus negative 1 is negative 3. Negative 1 times negative 3 is 3. And 3 plus 3 would give us 6. Negative 1 times 6 is going to be negative 6. 2 plus negative 6 is negative 4. Negative 1 times negative 4 is 4. And negative 4 plus 4 is 0. Now, out of the two here, what we are hoping for is that positive 1 works a second time, because if positive 1 works a second time, we will have our third solution and we can use our quadratic methods for solving. Now, 1 times 1 is going to give us 1. Negative 3 plus 1 is going to be negative 2. 1 times negative 2 is going to be negative 2. 6 plus negative 2 is 4. 1 times 4 is 4. And negative 4 plus 4 is indeed 0. So it did work out that 1, positive 1, worked twice. Now at this point here, since we do have it down to a degree 2, we can fill our variables back in. The number in front of the remainder, our 4, would be our constant term. It'd be our term without x. Negative 2 would be our term with x. And 1 would be our term with x squared. So we have x squared minus 2x plus 4 is equal to 0. Now this here is not going to factor, because if it was factorable, it means its solution would be rational, and it would have at least shown up. Yes, sir? So here or here? Yes. So when to switch it, really we're picking the solutions. What values of x are going to make the function equal 0? So out of our choices, we did have 1 and negative 1, and we were hoping 1 showed up twice. So I'm going to pick between those two. So we could have started with negative 1. We could start with 1, but we have to use one of them. So really I had the choice between these two to start with. So I picked 1. We could have picked negative 1. Because since they are solutions, it would give us a remainder of 0. Since I chose positive 1, I went with negative 1 next, because I know it has to work. Did it again, it worked. Well, I need my third one, and based off the graph back up, since it touched the x-axis, it looks like it touches the x-axis and goes back up. It means the number of zeros at that point should be an even amount. So it should show up twice. And it does. That means we really could have, instead of doing negative 1 second, we could have done positive 1 and then negative 1 last. Does that kind of make sense? The order in which we do the synthetic divisions for solving doesn't really matter. We've just got to make sure we do all of them. Because even on the last one, I could have done -3 first and then followed it up with -2. Any other questions? Does that make sense? Now, because there is a middle term, we have a bx term, we have an x to the first power, in the equation we're going to have to use quadratic formula. The other option is completing the square, but I think overall quadratic formula is a little bit nicer. So we take this here and we're just plugging in the values of a, b, c, and then simplifying. The number for a, the value in front of our x squared, since it's not listed, is understood to be 1. So the two places where a shows up, we're going to replace those values with 1 and go on from there. We would move on, and now we're going to plug in the values of b. Well, b, the number that's taking its place is -2, and the two places where b shows up in the equation is going to be -2. And lastly, c is our number without a variable. It only shows up in one spot, so we're going to fill it in as 4. Giving us -2 plus or minus the square root of -2 squared minus 4 times 1 times 4 all over 2 times 1. Well, our -2 is going to make +2. On bottom, 2 times 1 is 2. Now we do need to simplify everything inside our radical, our -2 squared minus 4 times 1 times 4. And -2 squared times minus 4 times 1 times 4 is -12. Now at this point here, we do need to simplify. We need to finish simplifying this here. Now, unfortunately, the 30xs will not let us take the square root of -12. But we do know that that negative is going to come out as I. So really, we're taking the square root of -12, pulling the negative out as I. So we're really looking at I times the square root of 12. And once we simplify that negative part of this here, it will tell us that the square root of 12 is 2 square roots of 3, or for us, it's 2i square roots of 3. Now we can say this is the final answer as long as the top two numbers do not share something in common with the bottom. Because we're looking at 2, 2i, and 2. So because we do have a 2 in common with all three, we can divide that 2 out. We can simplify that 2 out. Because the 2 on bottom, when we remove that 2, we simplify that 2, it's going to become 1. So there is not going to be a denominator written. On top, the first 2 is also going to simplify to 1. Our 2i, the I, not the I, but the 2 is going to simplify to 1, telling us that the last two solutions are 1 plus or minus I square root of 3. So we do have an irrational complex solution for the other two. Questions on this here? So the solutions for this here is -1, 1, 1, and I, 1 plus or minus I squared to 3. Questions on this here? Questions on anything we've done so far? Complex conjugate theorem. We've kind of talked about this already. We've talked about it, worked with it, done things with it. If A plus BI is a solution, then A minus BI is a solution. If we have one, we have to have the other. So if we look at a problem like this here and they tell us that 3 plus I is a solution, it really means that 3 minus I has to be a solution also. If we have one, then we have the other. Now, these problems here are the exact same as what we did yesterday with the radicals. We set x equals 2, x equals 3 plus I, x equals 3 minus I. We get the equations equal 0. We multiply them together and get our polynomial. But I'm going to be nice, and we're going to skip that this year. So you don't have to go through that whole process and do those. I'm skipping them, pulling from the homework too. Because it's not so much, I think, it's helping us see how they work to go back there, but it's more, they're just time-consuming more than anything else. The last thing we're going to look at is Descartes' rule of signs. Descartes' rule of signs tells us that for any polynomial function with real coefficients, so the numbers in front of our variables are real numbers, not i's, that the number of positive real solutions is equal to the number of sign changes minus an even amount. So if we count the number of sign changes and get 6, that means we could have 6 possible positive real zeros, or 4, 2, 0, or minus it by an even amount. It also says that the number of negative zeros of the function is equal to the number of sign changes of f of negative x, or is less than it by an even amount. So we get that number, and we can minus it by 2 to figure out how many possible negative zeros we have. So now to find the number of possible positive zeros, we take the function itself and count the number of sign changes from term to term. So as we look at this here, from x to the 6th to x to the 5th, did the sign change from one to the next? Yes, because x to the 6th is positive, x to the 5th is negative. So that would be one sign change. X to the 5th to x to the 4th. So that's 2. X to the 4th to x to the 3rd. Yes, that's 3. X to the 3rd to x squared. Now we're going from negative to negative, so there is no sign change. So we don't count it because it didn't change signs. X squared to x. No. X to our constant term. No. So the number of possible positive solutions, zeros, is 3, or less than it by an even amount. Or really, we can say we just subtract 2 from it till we can't. Because if I subtract 2 from 3, we get 1, yes? If I subtract 2 from 1, we get negative 1. We can't have a negative amount of solutions. So if we're going to have positive solutions for this here, we're either going to have 3 of them, or we're going to have 1. Okay. So we found the positives. Now we need to find the negatives. And to find the negatives, we're going to take f of negative x. We need to figure out what f of negative x is. Well, f of negative x says that we replace every x in the function with negative x. So all we're doing is we're going to plug in negative x in every place where there's an x. Out of all the terms, our negative 8 is the nicest because we don't plug anything into it. It's just going to be negative 8 no matter what happens. Now looking at this, Massively long equation now because we replace every x with negative x, so we have all these parentheses and negative x is put in. Let's look at them one at a time. We're going to look at this negative x to the 6th first. Negative x to the 6th says we're going to multiply negative x by itself 6 times, yes? Well, x being multiplied by itself 6 times is still going to be x to the 6th. We're not changing how many of them that there are. There's still 6 of them. It's still going to be x to the 6th. The main focus is that, yes, the negative in front of it. Because we're multiplying negative x by itself 6 times. So it's really, we're looking at that negative. As it's negative x. You don't have to write this. 3, 4, 5, 6 is what negative x to the 6th is telling us. Well, negative x times negative x, a negative times a negative is a positive. If I multiply this positive by our next negative x, it becomes negative. Do it again, it becomes negative and then positive. When we multiply a negative by itself an even number of times, it's going to become what? Positive. When we square a number, when we square a negative, it becomes positive. Anytime we multiply a negative by itself an even number of times, it's going to become positive. If we multiply it by an odd number of times, it's going to be negative, yes? So looking back at this here, negative x to the 6th, that x to the 6th is just going to be positive x to the 6th. Because that negative that we put inside the parentheses is going to become positive. It's not going anywhere. Since it was positive, it's going to stay positive. Now, if we look at this next term, because we have negative 2, the negative x to the 5th, well, we'll still have the x to the 5th, but that 5th power, is it even or odd? It's odd. So that tells me that this x to the 5th is actually going to be what? Negative. It's actually going to end up being negative x to the 5th. And we do have to multiply with the negative 2. Well, the negative 2 times negative x to the 5th, the negative and negative make a positive. Okay. So really, our x to the 5th is now plus 2x to the 5th. Now we do have positive 3, so let's look at x to the 4th. So negative x to the 4th. We will have this x to the 4th term, but is the 4 even or odd? Even. So we're multiplying that negative by itself an even number of times, which means that negative with that x is going to become positive. So positive 3 times our positive is just going to be positive 3, yes? Let's look at the next one. Negative x to the 3rd. Well, it's still going to be x to the 3rd, but that negative sign is still going to be there because of the odd power, making negative 3 times that negative plus 3. Are we starting to notice a pattern with this here? If that exponent is odd, the sign is changing. If the exponent's even, the sign stays the same. So our next one is negative 6 times this negative x squared. That power of 2 is even, so the sign's going to stay negative. Our next one we have is negative 8 times negative x. Well, the exponent's not written, it's understood to be 1, so it's odd, it would change. Or we can just say negative 8 times negative x is going to become plus 8x. Yes? Does this last number have an x with it? No, it's just, I say. So especially with f of negative x, if the exponent's odd, change the sign. If the exponent's even, leave it alone. And once we finish doing that, we're going to count. Sign changes again. X to the 6th, from x to the 6th to x to the 5th is positive to positive, doesn't change. Our next one is positive to positive, doesn't change. Positive to positive, no. x to the third to x squared. Yes, we went from positive to negative. We went from negative to positive and positive to negative. So the maximum number of sign changes, we're almost finished with this here, is 3, or less than it by an even amount. So, questions on how we found the number of positives and number of negatives? Okay, we're ready to actually write the answer. Now, especially as we've seen with this here, with our answer choices, our solutions, we can have numbers that are positive and negative, but we could also have complex. Our complex solutions are solutions with I, yes? Now, what was the most positives we could have? 3. What's the most negatives we could have? 3. What's the degree of this function? 6, yes? So how many solutions do I need to have? 6, yes? If I have 3 positive and 3 negative, how many do I have? So how many complex should I have? 0. Because if I have 3 positives and 3 negatives, I have how many solutions total? How many should we have? So there shouldn't be any complex. Now it does say that it's that number minus an even amount. So I start subtracting from the negatives. So I subtract 2 from the negative. So I could have 3 positives and 1 negative, yes? Which gives me a total of what? How many? It gives me a total of 4, yes? How many do I need to have? How many am I missing? So there's going to be 2 complex, because each row of this should equal 6, yes? That negative, so we have 1 negative right now, yes? Can I take another 2 away from it? No. So what I do, and the way I make sure I get every possible arrangement, is I reset the negatives once I can't subtract 2, and then take 1 away from the positives, 1 group of 2 away from the positives. Because I can also have 1 positive and 3 negative, which does give me a total of, so I'm still missing 2. And I do that removal of 2 again from the negatives till I can't, which gives me 1 positive, 1 negative, and 4 complex. Can't subtract 2 from the negatives anymore. Can't subtract 2 from the positives. So this is the answer for this here. All right. That is it. Your assignment for this is posted in Google Classroom, but that is